Hey guys, this is Mr. C. In this video, we're going to look at Introduction to Polynomials. And so when we talk about polynomials, the first thing you need to talk about is a monomial. And the definition that I'm going to give you of a monomial is a number, a variable, or a product of a number and one or more variables. And I'm going to give you some examples of these here in a second. Variable exponents in the numerator must be whole numbers, and a monomial consists of a single term. All right, so here are some examples of binomials based on the information I just gave you. 3x, and again, we're talking about, it says a number, a variable, or a product of a number and one or more variables. So here we have a product of a variable and a number. That's what we call a monomial. -5 is just a constant. That's a monomial. X squared y is a monomial. 2 cubed, x divided by 2. And remember, it said variable exponents in the numerator must be whole numbers. And this exponent here is a 1 on the x, which is going to make this okay to be a monomial. You really can't have denominator variables though. -2ab is fine. 1/3 xy is fine. And x to the 0, which would be equal to 1, is fine also. Now, here are some what we call non-examples. Here we have 2 divided by x. 2 divided by x, really you can't have this variable in the denominator like this with this whole number exponent and have it be a monomial. So these are not going to behave well. So 2 over x is not a monomial. A to the -1 is really 1 over a by a rule of exponents that we're going to find out if you don't know that already. Again, we have a variable in the denominator, so that's not going to be a monomial. And remember what I just said on the definition, you have to have exponents that are whole numbers, not negative numbers like this. X divided by y, we have a y in the denominator. You can't have that for monomial. The x is okay, but the y is not. And then x plus y is really 2 monomials put together with addition. So we call that a binomial. But mono means 1, and here we have 2 terms, only 1. All right. A binomial is a sum or difference of 2 monomials, and so just like I told you, the x and y. Binomial, the sum or difference of 2 monomials, 2 monomials, 2 monomials. So we're okay with all 3 of these. Those are called binomials. They're not monomials, but they're binomials. A trinomial has 3 terms. So you have a sum or difference of 3 monomials. Here you have 3, and here you have 3. And all of these are what we call polynomials, and poly means many. So it can have 1 term, 2 terms, 3 terms, as many as you want. And we call those polynomials, just as long as all of these terms are monomials themselves. So going back to this again, the monomial is a number, a variable, or a product of a number and one or more variables. So to be a polynomial, each of these terms have to qualify as monomials themselves. And it just takes some experience and some practice to be able to determine what's a polynomial and what's not. All right, so here we have a slide that says, which of the following are monomials? -1/2. That is fine. -1/2 is a constant. That's definitely a monomial. X divided by -9 is fine because the x is in the numerator. So we're good with that. B over A is not because of that A right there in the denominator. So we say no because of that A in that denominator. 2x -1, we would say no because of that -1 exponent right there. So that's not going to qualify as a monomial. This one, C over AB, is even worse than this one. Now we have 2 variables down here in the denominator. So that's no because of both of those guys right there. 10x to the 5th, that's fine. No problems there. That's a monomial. 4 squared times x is really 16x, right? Okay, well 16x is fine. That's definitely a monomial. x over 3y, the x is fine, the 3 is fine, but not that y right there because you can't have variables in denominators. So that makes it a no. And then 0 by itself is just a constant. So that would be a yes. That is a monomial. Okay, so what we generally do after that is we start adding and subtracting monomials, or polynomials, I'm sorry, and just to show how they're combined. So if you take two polynomials and add them together, you're going to learn that you're going to get another polynomial. And we say that they're closed under the operation of addition. So if you add two polynomials, you're going to get another polynomial. So what you do is you have addition. So remove the parentheses, plus, remove the parentheses, and then you just combine like terms. So negative 2x and 3x make 1x, and negative 3 and negative 1 make negative 4, and so my final answer is x minus 4. All right. Now, like terms have the same variables and the same powers, exponents with those variables. So we're going to do the same thing here with this one, addition. So remove parentheses, 4x squared plus 5. Okay, remove that. Remove these parentheses, so plus 7x minus 6. So we have a 4x squared. Is there any other x squared term? I don't see one. So we're going to bring down that 4x squared because there's nothing to combine it with. Now you have a plus 7x. Do I see any other term with just an x in it? And the answer is no. So I'm going to bring that one down all by itself. The 5 and the negative 6, though, can be combined because they are like terms. They're constants. 5 and negative 6 make negative 1. And 4x squared plus 7x minus 1 is then your final answer for that one. Simplified. Another addition. Again, we're going to remove the parentheses here on the first polynomial, negative x squared plus x plus 2 plus, remove the second parentheses, x squared plus 2x minus 8. Okay, now we're going to combine like terms. So I have a negative x squared and a positive x squared. Well, both of these are going to cancel because they're opposites of each other. They're additive inverses. So these are going to cancel, so they're gone. Now I have a plus x and a plus 2x, and those are going to combine to make 3x. So I've got a 3x there. Now I have a plus 2 and a minus 8, and that total is going to be minus 6. So 3x minus 6 is now my final answer for that one. Let's see, 2x. All right. Okay, again, addition. So we're going to remove parentheses, 3x squared minus 4x. Plus negative 3x squared is going to be actually minus 3x squared. When a positive and negative are side by side, the negative wins. Same thing for this one. Plus a negative 2x is going to result in a minus 2x. A plus 5 is still a plus 5. All right, let's combine some like terms. So here we have a 3x squared and a negative 3x squared. Again, those two guys are going to cancel. They're gone because they're opposites. I got a negative 4x and a negative 2x for a total of negative 6x. Now there's only one constant, and that's the 5 right there. So that plus 5 is going to just come down, and then negative 6x plus 5 is my final answer. And one more addition problem. Again, remove parentheses, minus x plus 4. And this was going to be a minus 4x squared plus 5x minus 9. And you can do that because there's addition in front of the parentheses, so nothing changes. Okay, now we're going to combine like terms. So 2x squared and negative 4x squared are going to become negative 2x squared. A negative x and a positive 5x are going to make a positive 4x. A positive 4 and a negative 9 are going to make negative 5. And that one is done. Okay, so now let's tackle some subtraction. It always seems like the worst of the two. So this time, when you remove the parentheses, the first parentheses are just going to go away. They are not affected at all. But the second one, they are. So you have to distribute this minus to both of the terms now, and it changes them. Negative and negative makes positive 3x squared. Negative and positive make negative 2x. So that negative minus right there flips the signs of these two when you remove the parentheses. Okay, so now we're going to combine some like terms. X squared and 3x squared make 4x squared. 6x and negative 2x make a positive 4x. And a positive 5 is just going to be all by itself because there's no other constant for it. And it looks like that's it for that one. Okay, another subtraction this time. Again, we're going to remove the parentheses. Negative 4x squared minus 10. And we're going to flip the second one again, just like we did before. Negative x squared, negative 8x minus 8x, and a positive 6. All right, so now we're going to combine like terms. Negative 4x squared and negative 1x squared is negative 5x squared. Okay, then we have a negative 8x next. There's no other terms that have an x in it, just a plain x. So minus 8x. And then we have a negative 10 and a positive 6, and that's going to give us a negative 4 at the end. And that's your final answer. Okay, another subtraction. Again, remove the parentheses. 6x squared plus x plus 1. Distribute plus x squared. Two negatives make a positive. Do it again. Plus x. And the third time, minus 3. Okay, combine like terms. 6x squared and 1x squared makes 7x squares. Positive x and positive x make positive 2x. Positive 1 and negative 3 make a negative 2. And that is it. That one is done. Okay, we're going to do this one the same way we do the others. Let me go ahead and get a different marker here. All right, let's try this. X squared minus 4x minus 5. We just removed the parentheses in the first one. And now we distribute. So minus 2x squared minus x, and negative makes positive, so plus 4 at the end. All right, so you got x squared and negative 2x squared for a total of negative 1x squared. I never put the 1 in front. A negative 4x and another negative 1x make negative 5x. And then we've got a negative 5 and a positive 4, and that total is going to be negative 1. Now, when you get to some of these numbers like this, negative 5 and 4, some people have a hard time with that, with combining signed numbers like this. So you could always have done this. Make 5 negatives here, make 4 positives, cancel them out in pairs, and whatever's left is your number. 1 negative, negative 1. Just want to remind you of that. It always works. Okay, a couple more. This one looks pretty simple. Let's see, x minus x squared. Okay, distribute, minus 1. Negative x makes positive x. So it looks like we have a negative x squared. I always start with the highest power of x first. A positive x and another positive x make positive 2x. And then we have a minus 1. And so that's our final answer, negative x squared plus 2x minus 1. And finally, our last one for this lesson. We're going to go ahead and remove the parentheses here for the first one. And then we're going to distribute negative 3x or minus 3x, same thing. Negative and positive x squared make negative x squared. And a negative and a positive 6 are going to make a negative 6. All right, so now we're going to combine like terms. Negative x squared and negative x squared are going to give me negative 2x squared. Negative 3x and negative 3x are going to give me a negative 6x. A 5 and a negative 6 are going to give me a total of negative 1. And that is going to be my final answer for that subtraction problem. All right, guys, this has been Introduction to Polynomials with addition and subtraction. Remember to like my video, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.